Hey guys, welcome back to my YouTube channel. First and foremost, I would like to thank all of you for all the questions that you have posted in the Padlet. So I'm going to go through these questions bit by bit so that you can understand more about all these subjects. And some of you did ask somewhat a similar question with your friends, so I'm going to merge these questions together. So let's get started. The question that many of you ask is about the law of conservation energy. So when you read through my lecture notes, I've already stated that law of conservation energy means that the energy cannot be created nor be destroyed. It means that this energy can be changed from one form to another form. So your energy can be either transformed into heat or into work. So how am I going to explain this clearly to you? So I'm just going to use this toy car. So for example, you have this car like just sitting there, but this car, for example, is driving recklessly. So it means that this car will have high kinetic energy. So this one, actually the kinetic energy is very low, but it do have some potential energy, very low potential energy, right? So here, this car coming to bump this car, so that car fall off because of the kinetic energy from this is being transferred to the other car. Another example that I can give you is that when you ride on a roller coaster. So at first, the roller coaster will be at higher altitude, means that it have high potential energy and it have not moved yet, so it have low kinetic energy. And then you remember, if you are riding on a roller coaster, it will be going like down this road, right? So wee, like that. So when it goes down like that, it means that it goes to a lower potential energy but high kinetic energy. So it changed from the potential energy here with low kinetic energy, change to high kinetic energy, and go down here with lower potential energy. The next most popular question is how do we differentiate between the enthalpy change and also the internal energy? So basically, for internal energy, it's just a fundamental thing. It means that it's theoretical, but in a real experiment, what we are actually looking at is the enthalpy change rather than the internal energy. Because when we talk about enthalpy change, what we are talking about is the relationship between the system and also the surrounding. But if we are talking about the internal energy as a whole, means that we are calculating the total energy of the whole system, which is only possible if we do fundamental experiment. Means that we need to control all the parameters. So now I'm going to explain more on the enthalpy change and also the internal energy. So we are going to make it into two. So this part is the enthalpy change, and this one will be the internal energy. Alright, so first and foremost, you need to differentiate between the formula between these two. So delta H is actually equivalent to delta E plus PV, and then for delta E is equivalent to Q plus W. Alright, so this Q is the heat energy and the W is work. So you need to know that for the internal energy is the total energy of the system, which is not used in a normal experiment. So normal experiment, we are using this enthalpy change instead of the delta E. So why is that so? So what is delta H actually? So if you can see, delta E is equivalent to Q plus W. So we can already write delta H is equivalent to Q plus W plus PV, right? So what is W? Work. So work Q plus negative P delta V plus PV. So from here, this one negative, positive, so you can slash it. So actually your delta H is equivalent to Q. That is why sometimes we can interuse this delta H. Sometimes although you want to calculate delta H, sometimes you just calculate Q equivalent to ms delta T. Okay, we are still discussing on the law of conservation energy. So in the law of conservation energy, it means that the energy shall be transferred from one form to another form. So some of you did ask, so how does this law of conservation energy relates to the exothermic and an endothermic process? So first and foremost that you need to understand is what is the difference between the exothermic and also the endothermic process. So for the exothermic process, it means that the energy is being released to the surrounding, but for endothermic processes mean that the energy is being absorbed from the surrounding to the substance itself. So I'm going to give you an example for an exothermic process. It means that for example, if you want to make an ice, so at first you will have like a quantity of water, right? For example, you have this bottle of water, and then you go and chuck this bottle of water inside a freezer. Means that this one, the energy inside this water will be released to the surroundings so that it can be turned into an ice. But on the other hand, if you imagine that this is a block of ice and then you just leave it at the room temperature, means that this ice will eventually melt. So it means that for this ice to melt means that it needs to absorb the energy from the surrounding, and then the absorption of the energy will break the bond. So from solid it will break the bond and then it will turn into liquid. That's why the ice will be melted. So from there you can see that the energy is being transferred. It means that if it's an exothermic process, means that it will release the energy to the surrounding. So the energy from here will be released out. But for endothermic process, it means that the energy from the surrounding will be absorbed by the water itself, by the ice, so that it can turn into water. When we talk about thermochemistry, we did learn about the delta E. So when you look back at the formula for delta E is equivalent to Q plus W, where W is negative P delta V. So when we talk about W, so what is it that you need to know? So when you calculate the work, so there are two different types of system. Is the work is being done by the system or work is being done on the system. So how do you differentiate between these two? So for example, if you have like a container with a piston that can move around. So for example, if you hit the container, it means that the force or the pressure inside this container will be very high. So in order for them to lower down the pressure, it means that these gases inside this container will push the piston up so that it can expand the volume, so that the pressure inside the container will not be that high. So it means that the expansion of this volume of the container, making it what we consider as work done by the system. Therefore, when you calculated your value of W or your work, you will have a positive value as compared to if you have a container like a metal container, and then it's very hot and suddenly you are going to do a thermal shock to it. So it means that you will pour like a very cold water on top of it. It means that this container will shrink, definitely, because of the pressure. So the system will contract, right, under the force. So it means that we consider the work done on the system. Therefore, when you calculate the work, the value that you get will be negative. Okay, another question, a good question from one of you is that, okay, what happened when you put a block of ice inside 100 degrees Celsius of water? So for example, this is your beaker full of water. So the water is initially at 100 degrees Celsius. So you are going to put your ice blocks, right? So this ice block, definitely, because it's an ice, so it should be like 0 degrees Celsius. So basically at equilibrium, it means that it's going to turn into room temperature. So for example, we are choosing at the end, it will be like 27 degrees Celsius. So what's going to happen? So it will follow the first law of conservation energy. So the conservation energy states that energy cannot be destroyed. Means that the Q for water plus Q for ice shall be equivalent to 0. So will the Q of water and the ice be the same? So the answer is it is not going to be the same, because Q water shall be equivalent to negative Q ice. And then why is it not the same? So Q water, like Q equivalent to ms delta T. So negative ms delta T. Although the S for ice and water shall be the same, but the mass of water and the mass of the ice is different, and the change of temperature in the water and the change of temperature for the ice is not the same as well. Because if you want to calculate the change of temperature, it should be like final temperature minus initial temperature. So your final temperature for ice is 27 degrees Celsius, your initial is 0 degrees Celsius, but for water the initial temperature is 100, so final minus 100 degrees Celsius. Another great question from one of you states that what is the correlation between the law of conservation energy and the Hess law? It's actually, it explains everything about the law of conservation energy. It means that when you have Hess law, remember you will have your target equation. See, your target equation can be either in the equation form, or it can be written in the question itself. So it means that you need to write your own target equation. So from there, you will be given like a stack of other equation with the delta H, right? So it means that you need to use all of these equation, because energy cannot be destroyed. It means that you have to use all this energy, and then you need to merge it together and then to get your target equation. So Hess law actually explain or give an overview what is the law of conservation energy. Okay, another good question from one of you is that for the formation of water, why is it the delta H reaction and the delta H formation is the same value? So when you talk about the formation of water, so formation of water. So when you want to know what is the formation of water, so it means that you know that you are going to form a water, so definitely your product will be water. So if you are calculating the delta H formation, it means that the amount of water is 1 mole. So now you're going to go what is the reactant? So H2O, so you need to have H2 plus O2, and then you need to balance this equation out. So when you want to balance this equation out, means that you need to add half over here, because you have 2H and you only have 1 O, correct? So this is the balance equation. And then if you go and look at the heat of formation, so heat of formation for elements in their natural state. So these are the elements in the natural states. It should always equivalent to 0. So therefore, in this case, what we can calculate, or what we can find, is that you will have the delta H of reaction shall be equivalent to the delta H of formation. Okay, this is the reason why. Okay, next up, many of you did ask about the acid and base chapter. So what is the difference between acid and base? So the first and foremost, like all of you have known, if it's an acid, the pH should be lower than 7, and if it's a base, it should be higher than 7. So how do you differentiate between strong acid and weak acid, or strong base and weak base? So you need to refer back to my previous video in the YouTube. So you go and search for the open session. So I've already explained about this as well. And then how do you know, like an overview? I'm going to just give you an overview what is a strong acid. So if you have a question with some attributes on the acid itself, if you read that the acid have higher conductivity, for example, or the pH is very low, it means that all these are the attributes of strong acid, because if it's a strong acid, it means that it will have high concentration of H+, which will give attributes of higher conductivity and also low pH. So, and then one of you did ask, what is the difference between base and alkaline? Is all base alkaline or all alkaline base? Alright, so the formula of knowing which one is just base and which one is alkaline is that a base is a general term where those substances with pH bigger than 7 means that that is obviously a base, but those substances that can dissolve in water means that it's soluble in water, that is an alkaline. So I can put it this way: all alkaline shall be base, but not all base is alkaline. Some of you did ask about the chemical kinetics. So the question is that, is the chemical kinetics limited to the first and second order reaction only? So the answer is no. We do have zero order reaction, we do have third order reaction, and also pseudo first order reaction, pseudo second order reaction. All these reactions are available according to the reaction that is being done. So only that for this semester the syllabus is only limited to the first and the second order reaction. Okay, and the next question about this chapter is about the catalyst. So what is the actual function of the catalyst? So the actual function of the catalyst is actually to lower down the activation energy. So how does it do that? So it means that for a normal reaction, it might have higher activation energy. It means that it will produce less product, because in order for a reaction to happen, it means that it needs to go through the boundaries, the activation energy. So it must have energy higher than the activation energy itself. So when you add this catalyst, it will lower down the activation energy by breaking the bond of the reactant, and then it will bond to the reactant and form an intermediate. And then this intermediate will have a weak bond. So this bond can be broken like easily. So after it has passed through the activation energy, means that it can bind to other molecules to produce the product. Some of you did ask about the half-life. So for the half-life, they are a little bit confused on the formula. So we have two formula, which is ln 2 over K or 0.693 over K. So actually both are the same. So you can use whichever formula that you feel comfortable and easy for you to remember. So another thing in the chemical kinetics is that most of you did ask whether you should convert the time to second or to minutes. So actually it depends on the question that you are answering. So you just need to be consistent on the formula and on the unit that you're using. So for example, if the unit for the K, for example, the rate constant, if you're using the value of K is in seconds, so it means that the time for all other things must be in seconds. So if it's in minutes, so the rest of the things should be in minutes as well. So this is the end of our discussion session. So I wish you all the best for your final exam. Please do study smart. Please do well in your final exam, and thank you very much for the whole semester. Thank you very much.